Okay, in the second video we're going to look at our LAS data set in the Arcmap environment and look at a couple of the options in terms of working with the data and visualizing things. So here's our data again, our LAS data set, and its referenced point cloud data is contained in these 4 folders. I'm just going to drag that onto the desktop now. And the first thing you'll notice is that when you bring an LAS dataset into an environment, you'll see the footprint of the relevant tiles of point cloud data. So here we see kind of this L shape of those. Also, it defaults to the elevation data here, so you can see our range of values from just over 700 feet all the way up to 690 or 1695 feet. And so what we don't see is any of the points. And that's because the system, in a sense, the visualization, limits the number of points that are visible. So if we choose our zoom tool, and I'm just going to kind of zoom into a small area here. Now you can see our points as represented as elevation. And what's interesting here in Pittsburgh is that you can see right here is a bridge going across the river. Now, there are 2 ways of understanding data or visualizing data within Arcmap. One is, of course, to use the LAS dataset toolbar. And I do want to point out a couple things here. First of all, you'll notice that it gives me options in terms of how I can move around, profile tool options and pan tool options. We're going to get to the profile tool in a minute. This indicates which LAS dataset we're using. And then these 2 buttons indicate whether I want to visualize the data as points, that's where we are right now, or as a tin. Now under the point option we can do elevation, just what we have right now. We can have class, I'm going to click that real quick, and again in this case we have unassigned as gray, our ground is our brown points here, our overlap and reserved are our purplish pink, and then we have some transmission tower data, and then of course our model key. Water, you'll notice actually there's quite a limited number of water points in this area, even though this is all river. So it's important to understand what you're really going to see. Now I can also identify it by return. And again, so first return, second return. Okay, and so again we can kind of see how that first return landscape looks. Now I can also look at this, and I'm going to go back here to elevation. I can also look at this from the standpoint of change our visualization from point cloud to tin. And click on that. And what you'll notice is immediately a tin surface is built across here. The tin surface is using a subset of the points, and the first thing that I want you to notice is that the tin characteristics are dependent on the scale, in other words, how far we're zoomed in or zoomed out. And what I want you to know, we're just going to look at these buildings right here, and I want you to look at just the roof line of this area. Now when I zoom in, you'll notice that I get much better information in terms of the tin about that roof line. And if I zoom out, I'm going to see that that changes. Each time that I zoom out to a certain level, my tin is actually going to evolve. And you can see that slowly happening in terms of my tin features are simplifying. And there it goes. And I'm going to zoom out a couple more times. And the tin rebuilds as fewer and fewer points are used to build it. Now, our tin surface, the one advantage that we have is we can very quickly look at aspects, or we can look at certain characteristics, aspect and slope. So for example, I'm just going to put on slope here. And now we can see the areas of relatively high slope and relatively low slope. We can also look at it from the standpoint of aspect, north facing, south facing, etc., which gets a little complicated with these facets. We can then also filter our data, and in either case it's worth doing that. I'm going to filter out, for example, our ground features, and you'll notice immediately that my aspect becomes more meaningful. We can also, for example, look at our elevation. And again, this is in a sense, we were thinking about this as a bare ground tin. when we do those things, then that's in the dynamic, in a sense, in the toolbar. I can do the same things here. I'm going to go back to our point data, and you'll notice that the filter that I applied here is applied here. So I'm going to change this to all. All of our data is there. All of those options can also occur here in terms of my symbology. You'll notice that I can have either, and all those things that I added in my toolbar are now populated here. And in this case, what I'm interested in is I can now turn on or off any one of these. Now, if I hadn't done that through the toolbar, I can do, and I'm going to move a couple of things off of here, I can remove options here as well. Or add them here in the same way that I did in the toolbar. You'll notice they're all listed here. What we want to do also is note that we can filter here. The reason that sometimes I think it's worth using this filter is that you'll understand what a filter actually does. So for example, when I select ground, which essentially is our DEM filter, and we're going to build a DEM in the next video, that means that I don't want all of the classes. I only want the ground and the model key, but I do want all returns. So ground means doesn't matter what the return number is, I want only those who are classified as ground. Now in contrast, our first return, that is our surface model, that's all of the stuff, we want all classes, doesn't matter what it is, but we only want the very first return. So we need to understand that filters modify either return value or class value. Okay? And again, we can do that here, or we can do it in the toolbar. Okay. Now again, what I want here, we've done, this is I want all. In a sense, we're going to just deal with all of our data. And we're going to apply that now. And what I'd like to do next is just very briefly look at our two visualization tools. We can see them right here. And again, I'm going to do, when we deal with visualization, you have to be a little sensitive to what your computer's performance is. And in this case, I'm going to do some relatively small visualizations because I don't want to bog down my system. Now the way that we do this is we begin with our profile tool. I'm going to click on that. And what I'm going to do is stretch a line across the area of interest. So there's a bridge right here that I'm kind of interested in. And so I'm going to click on it, drag my line across, click again, and then move to the side. Now I only want to capture my bridge. Now if I go too far, you'll notice that that exceeds the point limit. I'm not interested in getting all of those points, so I'm going to bring it back in and just look at my bridge. And there you see the bridge in profile. Within the profile tool, it's important to note there's also a elevation change tool, and this tool allows us to look at the difference in height between things. So for example, if I was interested in knowing between the bottom of the bridge surface, and the top, I can in fact measure that, and it will give me both its start elevation, its end elevation, and its difference. That's an important tool to use. We can also use it to measure between two features. In other words, two features that are not equal in elevation. I can click on one location and go up. Even though they're very far apart, I can see that in fact in this case the start elevation, the end elevation, and again the difference. And within these profile tools, that can often be quite important to understand relative elevations and the change in elevation. Okay, now the next thing that I want to do is open up our 3D view. I'm going to click on that. And what the 3D view largely allows you to do is rotate a feature and look at it in 3 dimensions. And so here is our bridge surface, and we can see it in a number of different views. Now the other advantage that we can certainly do here is we can, again you'll notice right here, this is our Z exaggeration. We also have some options here in terms of our point size factor, and sometimes you're going to want to make your points smaller. In other words, it gives you kind of that ghosted image. Or you can make your points in fact quite a bit larger if you kind of want to fill in and look like that. And again, in any one of these environments, you'll see that they do different things in terms of how we visualize something. Okay, so again, we're going to go back to our standard size dots. Oops, grabbed the wrong one there. Our standard size dots, and in fact, I'm going to make them a little bit finer than the standard one. But in this respect, and then I'm going to change my background color. Sometimes it's appropriate to have something a little different. Okay, so for example, there's our gray background versus our, and I'm going to make that a little bit darker. I don't want quite black. But again, in this case, now I'm going to again rotate through. Certain colors work better on certain backgrounds. Okay, so again, that is our three-dimensional tool. Now you'll notice right there, I want to point something out, that this can bog down quite a bit, and so you have to be a little bit careful with how much you ask your 3D viewer to do. So again, I'm kind of moving things around here. You have to be a little bit careful. Sometimes this will crash your system quite easily. Now again, so here is our basic model. The other point that I want to make, and I'm going to close this, is that if we change our elevation surface, we've now just made that a 10, you'll notice that my cross-section hasn't changed. But if I bring up my three-dimensional view, when I change that to a 10, the entire surface in the view is made available. And so here is our entire area that we can see in my desktop, and that's what's going to be available here. Okay, so again, be careful with some degree those visualizations. You have to make sure your system is not being overtaxed, but it's a good, interesting way to visualize point cloud data. In the next video, we're going to talk about how to derive surfaces, elevation surfaces, in other words, DEMs, and terrains or digital surface models, as well as intensity surfaces and our height differences. We'll see you in the next video.